Ladies and gentlemen, thank you for making the effort this evening and turning out to our 5th technical event, 6th of the year so far, with the quiz included. I think most of you know, my name's Trevor. I've got the honor of being branch president this year. I think we're in for a slightly different presentation this evening, which I'm sure we're all going to enjoy. So without sort of further ado, I'd like to introduce Lee Jenkins, Director of Operations for Weir Minerals. That's going to give us a presentation over the horizon. Lee.
Thank you, Trevor. 2 hours, guys, so anything could happen. Yeah, so as Trevor says, I'm the Director of Operations for Weir Minerals. What I'm going to show you, we could have done 2 or 3 different presentations, but we wanted to get this to you regarding state-of-the-art technology, where we're at, single-piece flow. We're going to offer it to all of you guys to use for the simple fact we've obtained a substantial grant, which we are a demonstrator site, so you've got free access to this. I'm going to give you a very quick introduction to Weir. We're a mining pure play. We are several billion-pound turnover. We have 5 mineral foundries in the division, and we have 6 ground engaging tool foundries in the division. Just Weir in numbers, operating 60+ countries. When we were founded, annual revenue. This is 1 year out of date. We do go live with our latest numbers the end of Feb, so this will change. Sustainability is at the center of what we do. And this is just a graphic that will get shared with everybody. It's quite busy. Right, the world map outline has vanished with this, but the global service network, we're in every region apart from Russia. We closed the Russian office March of last year, obvious reasons. However, what we observed and what we felt, the region that I was responsible for in Europe has now merged to form a larger region called EMEA. So that's Europe, Middle East, and Africa. So this is Europe up here, but now we're down here. And what that has meant, we now have 3 foundries in our region, constituting over 50% of the divisional capacity and capability. We've noticed a slowdown in the market. So as a business, as a UK business, what can we do different? What can we embrace? Can we bolt an agile, fast and flexible manufacturing hub onto an existing 15,000 ton a year momentum business? So we recognized this 2 years back. When we came out of COVID, we noticed a change in the market. A lot of IP product. Historically, it's been relatively slow getting a new part to market. So it can take, we've just finished a program now, which has took over a year. So we thought, how can we exploit this? So we came up with an agile model. So the 3 founders that we've got, so this is Todmorden. As you can see, we're responsible for this region, but our biggest customer is still Canada. And this goes into the oil sands in Canada, largest revenue stream for Weirs. However, now we've got HBF foundry in Africa. Due to cost considerations, we've moved some of the load from Canada there. And then you can see the rest is around the African region. And then we've got Isando, which does relatively small components, and it's predominantly for Africa. But we've got 3 metal streams now. So we got together. I'm very, very fortunate because I do have a team of superstars who work for me. And I set the challenge on initially, can we scan product? We have 2,800 live tools at Weir in the UK. 1,000 of those tools are used less than once every 3 years. So the cost to store, manufacture, and repair is huge. So one of the ideas, could we scan a tool Could we sit it in the cloud? And then when Trevor here comes on for a part he's not had for 30 years, we will decide, do we do additive, subtractive? You've got to pay for it though, right? But we're not going to maintain your tool. So we looked at this and a couple of the guys came up with the tool. I've tried to put it into a running order, but it does jump around a little bit. So we believe we can get patterns done 50% quicker, 7% in energy, plus all the tools that this equipment is going to print is recyclable based on polylactic acid. It also has an auto-correct function where it will correct its tool path as it goes. Right, so first things first, could we find something that would be the start point, which would be scanning, and you recognize excellent employer with Made UK, you recognize all these. These are the guys who we are functioning with on a day-to-day basis. So, doesn't look particularly exciting, and even when the videos play, but look at the screen. So this is a guy using a metrology grade scanning unit. That thing there will be 6.5 ton. It will be over 2 meters diameter, and it's clamped into a machine center, and it would take the guy an hour and a half to inspect it. So I'll set both videos going. So Renisher probe at the top, scanner at the bottom. Supported with lead audits, we can take the detail from these units and make procedures. We want staged inspection, 0 defect bench. Everybody picks up an error right at the end of the cycle. We want to pick it up much, much earlier. No fault forward. And one of the big things that you'll hear me always bang the drum about is non-value added, what the customer doesn't want to pay for. He doesn't want to pay for a guy taking 2 hours to inspect that. We can build it into the cycle time, but not all our equipment can do 100% SMED because they're not twin table. New equipment coming this year is. So we found the scanner, we got the accuracy, then we thought, how could we implement it? So we could scan an existing tool, take a new design. Every design for Weirs comes as a 3D model. We touched on, we've built the Digital Academy, where we're going to train engineers. I'm going to touch on the funded second robot that's coming, because a big chunk of that is with a company called AI Sync, who are developing a drag and drop software. You'll drop it into the envelope and it will do the macros that we've written, and it will also program the tool paths with an autocorrect function. Same data, sorry. The magnet simulation, we will decide whether we're going to additively make it or subtractively make it. The AI transman will go into a manipulator in our GP30 in Fettel. So blue sky, it will recognize the part, it will pull the data, it will dress it to a tolerance we set. Same information goes to the machine shop, goes to inspection for an off-tool sample report, drops into a pump assembly, automatically generate a certificate. Some of the benefits is no real estate for pattern storage at this stage, rapid availability. We can get sign-off almost immediately from the design center of origin, and then we can decide whether we're going to commit to production. And at that stage, do we print a pattern? Is there enough volume? Do we not? Do we continue doing it in an agile manufacturing scenario? So this is our additive system overview, and you can see there's some video playing. I think we recognize the fact that pattern making is a skill that needs reviving. I'm already working with the FICME writing packages at the minute. So this unit is more of a CNC background. We've already attracted 140 youngsters interested in taking this forward. It's going to be the biggest rotating table available. We can use polymer pellets, print speed up to 24 kilos an hour, and I'll show you what that looks like. interlocked cell. We can put a gantry on it to extend it, which we'd probably do with Amiga. This is the key. So we will lay the material down through an extrusion head, and then we'll mill it back to shape. This milling functionality will also double for sand milling. Again, a project we're working with Amiga on. This is the software, £500,000 grant to tailor that software for us to Weir design criteria. And this is the thing, it has a module within that detects if there is an image issue, and it simply corrects and reformats. So initial trials, we've done 2 tools. We've got a third one on the go today. This tool here has been run now for over a year. And this is one for the UK, that's one for Africa. So the goal there, which is a bold one, but we can do it, is to train engineers so they can actually know how to design a casting. And I think that's what we all would like. That's as live as I could get it today, but that's how it extrudes. It does look unusual, but that's why you have a milling head. We can lay it down quicker. So what's the next step? So we do some life cycle demonstrations. It's supposed to have been first week in Feb, now going to second week of Feb, but I will give you the ICME an update to that. Factory acceptance tested in May. We've already chosen the supplier of the hardware, and then this is key, installation in Weir in June. By definitions of the grant, and I'm going to touch on how we've covered the costs for this, we are a demonstrator site. But I'm going to add to that, we're also a site that can do 20-ton liquid metal. I don't think there's anybody in England who could do a ductile iron casting as big as we can, and we don't do any. But by terms of the grant, we're going to invite companies with certain synergies, and if that means we'll make you a casting, we'll make you a casting as well. We're on the 60% loaded now. We've got 3 facilities, so this is the reason, or one of the reasons, went for agile manufacturing. Meanwhile, if you want to send something up, or if you want to come and have a look at Weir, we welcome that, and we support the ICME, CMF. Anybody wants to come up and have a look, we'll show you what we are. So step 2, we can print patterns. We can print the biggest ones, quickest ones. So what if then, if we could use this in an automated inspection environment? What it is, we produce very large cast. I say very large casting, 12 ton. And because we export, and I will use the phrase Canada, if we get a component to Canada, this fits in a casing. If it doesn't fit in the casing, it's several $100,000 an hour to rework it because you switch the pumping line off. So we have to ensure that every part that we send fits a casing. We also in the middle of something called Project FICME, where some of the data between the regions is a bit conflicting, so there's rogue parts getting out, but we're spearheading this. So first thing we do, I'm not sure if anybody's used to scanning castings, is set targets up. And again, we can showcase it. You're going to see a video of this. So then we scan the casting, and you can see the size of these. We're doing 6 of these a week. This casting, you can see, it used to take about an hour to scan, about 3 hours to crunch the data. It's a 20-point laser light inspection glove. And again, doesn't look particularly impressive until you see the computer screen. We've improved it since then. We've got a table that goes underneath. Well, that's producing a single skin model now, as fast as you can actually manipulate the scanner. when we showcase this, the regional managing director, the only word he said to me is, when are you buying more? We've had it 2 years now. So step 3, we align it all to CAD files, everything in Weirs. We're very lucky. We haven't got any paper drawings anywhere. Jack doesn't like them, so we don't bother. We run a macro then, and it overlays the scan against a fitment model, and we get red areas where it's too big. So currently what we do, it gets transported back down to the fettling shop, marked up in pen, and we get a guy with a grinder grinding it away. This can take 3-4 iterations. So again, we'll default back to non-value added. Customer's not paying for this. We can't build this into his cost. We can't build poor quality or poor inspection into his cost. So we came up with this, one of the engineers did, this Vertex projection system, and we viewed this at Sheffield Forge Masters. And so what the plan is, to when we scan, we will project onto the cast in the area, and we will not move it. We're going to build a fettling booth or a upgrade booth next to the robot, and it will scan it, and when it turns green and the guy's finished, it's done. No transporting it half the way around the site. So these are the trials how we did it, by putting putty on, then pulling putty off. But this does work. So how do we make that easier? All right. So we put the Vertex unit in. The goal is to drive a 10-ton casting, stick it on the robot, and then this is what happens. Again, reducing non-value added. And you're going to be surprised, the guys especially who know tolerance. Net weight of that 7.4 ton, and we have to dimensionally accurate to CT10. The designs that we're building at Weir to protect IP are quite staggering. Sand milling. So again, same robot. What can we do? We're actually going to have a spare robot later this year because we've got a prototype unit. So I did have some footage, but I've had to take it out. So I'm just going to show you the robot that we're getting. So the robot we're getting has got an extruder on it. It's got a milling attachment on it, and we could put scanner attachment on it, etc. We've been working with Amiga with this, with Mark Lewis, and the reason we cannot present anything at this stage is because we're not sure how the hardware and software is going to interact with Amiga's core system. But we will be doing this in conjunction with Amiga. Everything in the factory, I've been there 12 years, is Amiga, and Amiga are our chosen partner. This is just an overview of the size of the robot. And it's a Dutch company that we're using. We recognize that sand milling, a lot of our shapes are relatively simple. We've got a supplier agreement with VoxelJet on sand printed cores. We've got 80 SKUs now which utilize sand printed cores, and the cost has come down so dramatic now that it's commercially viable to use sand printed core. We are producing items now that I don't even think we could produce without sand printed core. We are looking at specialist sands as well, from ceramic to real special stuff. So this is just an overview of the robot that we're going to get. This is going to develop with Amiga. We've got some trials we've already done. The Weir parts are relatively straightforward. Some of the cores which we'll print the speciality. So a lot of our shapes are really quite general. So I'm going to move to the sort of the back end of this presentation now. We've also got a project called AdCast. That's another robotic cell, and we can build product wire arc manufactured. Selfish thing that we've got involved with is we can repair castings too, which nobody wants to make a bad casting, but we can repair the items. And we're also thinking of getting things to market quicker, whether we actually just build it in wire arc, just proof of concept. So it's direct energy deposition. Our unit is ready to come. I will show it you. The foundations are all in place. We do have some complications on timing where we're going to put it, but this is ready to come down. It should be installed in March. This is some of the examples. You've probably seen these on YouTube. I couldn't put our components on, but we've done a series of components as well. This actually is our unit. That's one of my engineers there, young Reese. So again, you guys are welcome to come up and have a look at this. It's going to be in the same shop. The area that we're putting it, we're going to make that state of the art. So we're going to have 2 robots. We're going to have robotic inspection, sand milling, state of the art upgrade, as well as still doing some pump assembly. When we touch on laser cladding, we have another cell at Weir, which is laser cladding. Everything we do is, predominantly everything we do is Weir related. So we've got 2 robotic cells depositing hard materials, almost like hard facing, but it does it without putting too much heat in. So we can extend the wear life of our critical components. Of course, it doesn't do the business case any good because we're not making spares. But if you can imagine you're pumping in the Gaza Strip, you don't want to ever return to the pump. We'd do something like that. So this is another value added that we have at Weir at the minute. And again, IP protection, extended wear life. We do run it as a profit center. In theory, we can do product repair. We've applied for some grants for this. And we see sales growth, reduce asset downtime. If you can imagine, a large pumping system could be several $1 million revenue if it's down for a day. So we can hard face these materials very, very quickly. And there's some benefits on cost saving. Again, we're coming back to this competitive advantage. Weirs want to simplify and standardize a lot of the products. So do we, but we do see an option in the Weir market for this. Again, it's all about speed to market. We can get it to market very, very quickly. Cash flow. Again, we're not tying cash up on product development cycles. If we delay a product launch, lets our competition in. Again, efficient resource allocation, it's multifunctional. The customer feedback is great. It works really well on some components. We are developing on others. You do get issues trying to get it into some areas. Development cycles, we see that being a big part of Weir. And again, it's robotics. It's a class 4 laser. So it's shielded, everything's done automatic. And this is one of the strap lines that we've got. If we can get product to market quicker, reducing costs, minimizing risk, it gives us greater profitability and competitiveness. None of the other facilities in Weir have what we have got. We support the other facilities, but we are ahead of the curve. And I know you're all asking how we pay for it. So we have been very, very lucky, and Pam's helped a lot with this, where we get industrial energy transformation funds. So we've received £1.6 million in funding this year. We've had to put 350k to it. Working with Innovate UK, we've got a call on Wednesday on the latest run of sustainability. injection. We're working with lots and lots of universities, and I had a quick catch up with Pam. There is a paper going to go out. I could have done sustainability, I could have done digitization. We've had some good success getting sand waste into a low value byproduct, into low impact concrete, and that paper is going to go out, and I'll share the paper so you guys can all read at that. But we've done that with Cardiff University, but it's not easy going through the grant funding. We started back then, and we're just going into 2024, and we've got a huge install this year. But everybody's supported us, from Warwick University to Omega. We've worked with William Cooks on heat harvesting. We've shared what we've done, and we will continue to share what we can share. None of that's done though without the superstars. I think it's fair to say, Pam, we've got the biggest install membership of the Institute from one site. And there could be another 3 soon. Yeah. So, cool. So this is the area where all the new materials go. And we are actually going to remove the assembly bay and strategically position it close to the customers, because we supply in Europe. So all of a sudden this shop then becomes the nerve centre of Weir, EMEA. That's our assembly shop at the minute. So if you look at that, where this handsome devil is at the back, there's a new concrete plinth ready for the second robot you've seen. First robot's going down here, automated inspection. So we will keep this area here for doing some pump assembly, because at the top of the shop, we've got a performance bay. And we're also going to extend that into a slurry performance bay. So when they're designing pumps, we can put slurry through, see what they're doing. Not every pump is done this way. That's it. Any questions? Anything you want me to go over?
I'm interested in terms of the sand milling.
Yep.
Because that's only one part of the whole process.
Mm-hmm.
So could you maybe explain, once you've done the milling, what's next?
So long term, I see we're becoming an assembly shop. So we get lots of one-offs. We have a real issue slowing down field engineers who come up with a dream. You know, if we put a 5th vein in, if we extended the spout, which is great. The business model at Weir is each facility capex has its own tooling. So if you can imagine a tool as big as this stage, complicated, could be 60K. We may only use it once. So we're educating the engineers, and we'll look at it. So we may sand mill the mold. If the guys come on and say, look, there's a potential of being a run, we would print a pattern, which we could recycle. If they come around and say, look, it's a real one-off application, this, we would look at either milling sand core box, making a core out of it, then milling the mold, putting it together as an assembly, or a different way. We'd give various options for it, but it's just close enough to the customer where we don't want to commit to a pattern if we don't need it. So sand milling is just, we fell into it. We was talking to Omega about putting a system in anyway, developing the software for the hardware. We realized that there is a certain amount of synergy with Omega. However, we've got no idea how to clamp it, how to manipulate it. That would be Omega's strong point. So sand milling is just another tool in his toolbox. We're already printing cores or getting printed cores every week. The option of doing a prototype pattern which we could shred and reprint, everything's there to get to market quicker and outrun everybody else. And if the future is as rosy as we hope it is, anybody in the industry can come up and learn how to do it. Yes, Pam.
So yeah, really interestingly, and it's, I mean, we've got so many great projects and exciting things to sort of be working on. It must be great fun for the team, first of all. So congratulations on the ambition, and I know you've got the support of the company, which is a big thing, obviously. I was just wondering, you were talking about looking at scanning for the reclamation or the upgrading. That was the term. That was the clever term you used, wasn't it? For getting.
We don't repair castings, we upgrade them.
Upgrade. Yes. Thank you. I was just wondering if you're, I'm wondering if you get repetition of the same areas that are raised spots or whatever, and whether then you can do an interesting route to tweak the pattern and the tooling and the mould.
Yeah, that's a fantastic question, Pam. So, the guys who've been looking to come to Weir know we've got a replicast line, small fast loop, 2.5 metre square fast loop, all plated patterns, relatively easy. I say relatively easy, it can be done, and we get very few problems from that. When we get to the heavy bay, it's more of a craft orientated scenario because we're tight for space. We've got vertical stacking systems, you name it. This item, for example, has 14-inch open heads, which have to be dressed within 1 millimetre. So it's very, very difficult with all the gauges. So what we've decided, if we scan it and find it, it's predominantly always the feeder heads, right? And this is, I touched on Project Fix It. Project Fix It is definite, as it says, fix it. Make sure the patterns are right. But where we've got a feeder head, we have a requirement in Weir to hit a minimum soundness level. So regardless of if I wanted to take a flyer and put 2 feeders on it, Magma system will say, no. To hit the threshold, you will have to do this. And then fettling a 14-inch open feeder at 750 Brunel is a task. And I haven't put the robot on. We've got a Klansman GP30. And the idea behind the scan data is we can feed that in. It recognizes the part, it will scan and say, oh, this is 1 millimeter oversized. However, that's taken a little bit more doing, and I got the headline 2-3 weeks ago that Klansman are delaying this, but we were working with Klansman to get ahead with this. So you're completely correct. We put the patterns right, but then we've got areas where a fettler has left it. We have to be very nervous because if we put it on the robot, I'm not sure if anybody's seen a Klansman GP30 run before. It runs on force feedback. So you've got a guy in a cab removing metal at 45 kilowatts instead of 3.4. If he goes 1 millimeter deep, that's a big paperweight. Although the outside edge does nothing, the argument is because the way that the pumps run, almost, if you classed it as lights out, it could breach the pump, and then you're into claims, warranty claims, leave flying over somewhere to try and defend it. So it's a balancing act. But this is why, again, we touched on non-value added. Where we detect it, we're going to put it right. Until we can get to such a stage where somebody's much smarter than we are at putting feeders on. You know, we remove these feeders mechanically. We've got the biggest cannon you've ever seen, right? So this thing fires them off, and you know it's explosive almost. Now 14-inch feeder neck mouth, it's huge. So we take it down with the robot best we can. The robot works by a Z plane. You touch. You can see the grinding there. So you touch on a flat plane. It's easy. Impellers, throat bushes, FPLIs. If it's a flat plane, you zero it to the point you want it. The guy drives it with a force feedback joystick. Cannot go below that point. Easy. It's even cut machining out to a large extent. But when we're on a curved surface, it's tricky. So that's why we're going for the scan data. So we tend to take the robot. You can see it's quite heavy as we've fettled that there. And then a guy unfortunately has to finish it, and then we have to scan it. But
you also mentioned that you were working, some of this has been done with MTC.
Yeah. I think you're going to see the same presentation again.
Yeah, well, I think
Theirs will be better than mine because they've got the footage.
I'm really interested. I know that they do have visits, you know, they're very interested. I mean, lots of projects they're doing. I've seen the kit list where there's printing in resin,
Yeah.
the recyclable resin.
Yeah.
And they're really optimistic because obviously that is one of the big issues with printing patterns, isn't it? You've got a lot of waste.
It is. if anybody wants to come to Weir pre-installation of this, we've got 4 printers running now, ranging from metal printers to large industrial printers that you can get a hold of. And we print parts of pattern. We do composite patterns, so we've got aluminium machining through CNC. We've got polymer printing. Every insert we make for an impeller now is printed. And the beauty about that, we do it lights out. So some of you guys, I don't know everybody, I'm sorry. So some of the guys in a jobbing facility will invariably use a hammer to take the loose piece out. We can reprint it. So we've got them now down from an impeller vane from 21 kilos to 3.2 kilos because they're all hollowed out, but we do still break them occasionally. But everything we do on that is printed. So it's a real hybrid of what we do. And again, the more safety critical or the ones that need specific sand grades, we print those, we sand print them. But if you can imagine, I like to take them, we're printing 2.5 meters down. So there's some real big lumps. And the guys have took to them in the factory. They don't see it as a threat. They don't see it as an insult. They see it as another tool that they can use. And they've adapted it.
In terms of the layer cladding,
Yep.
I was talking to a fan the other week who are looking into it for dye repair.
Yep.
And dye wear and dye hardness. And again, this is something that I know the NTC is looking at, so I'll put them in touch with you.
Yeah.
Again, if you say it's toolbox, anything that makes you
Correct.
more competitive.
We're very fortunate at Weir because we have Weir added manufacturing services, which is more of a prototype-based approach. We have some real clever guys in there who will take a system, prototype, design it, and then we will just railroad straight in and pinch it and productionize it. You know, so we part fund it, they part fund it, everybody wins. And if we can see a competitive edge for anything that we're doing, we want to be the differentiator, especially in Weir. We want to be the go-to site. We want to get things to market quicker. And again, this is going to be quite unique for the UK. This is open to you guys. Everybody knows Pam, everybody knows Trevor. I'm the most welcoming guy there is. If you want to come around and have a look at what we're doing, whether it's digitisation, sustainability, general nosy, just drop one of us a call. I brought a box full of cards which people can take. And we do try and support the industry wherever we can. We support the CMF, even the WFO. I just thought I'd show you something different. We're very, very fortunate that we have a real strong CEO, CFO, and a president who understand that the metal streams, we need to be at the forefront of all the technology. So we make sure we are in pole position if we can.
There's actually another webinar tomorrow evening as well at 7 o'clock that we've been promoting, which is about robotic tool automation as well as free. So if anyone who's interested and has to see the link, then contact one of the team and we'll send you the link.
Do we have any other questions? Anybody else? Anything online? So how do you see the future of this, Lee? What's the ultimate goal?
The ultimate goal is we're going to transform from what we'll class as a momentum business, you know, doing 300 ton a week, to having a certain portion of the business doing this very, very intricate, fast, for the sake of a better word, very, very clever route to market quicker. And we're going to knock some non-value added out. We have to knock the non-value. We recognize the fact that the UK is not the cheapest source. So we've got to do something different. We've got to do something that others can't do. So again, we've now inherited 2 other foundries, low-cost source. So of course we'll load those, take the advantage of those. But we see this being a huge benefit, not only to Weir UK, but to the UK cast metals industry as well. And this is happening. This is not Lee Jenkins' Death Star moment. This is going in, right? Please don't think I'm the guy who's come up with all these ideas. I do have a team of superstars, which Pam's met. I think you've met most of them, Trevor. I really do have some movers and shakers. One thing we're very good at, Weirs, is failing fast. If they don't work, we move on to something else. Right, but we really do see this as a competitive advantage for Weir. Get it to market quicker, protect the business, and you're all welcome to it.
Yeah, I've had the good fortune to go there several times, and you can see it's a team event. When you've got so many complex projects, you can't just have it under one person. There's got to be people standing up and actually delivering what the results are. So I think, well done, Lee. I think
Thank you.
As a team, Weir are doing a cracking job.
And the beauty about the team is 35 years old onwards. I've got a real strong succession plan.
You always know when things are going well because you spend so much time on holiday. Yes.
Yeah, I don't like the UK at all. So yeah, look guys, if you want to speak to me afterwards, if you want to arrange to come up, if you want any information, if you want to come and see something different, one of the other big strong points is our digital footprint. Most of what we do is digitized, so this lent itself straight to that. We don't like paper.
Thank you very much, Lee. Adam, could I call you to do the next event, please?
Well, Lee, thank you for
Anytime.
this presentation.
Anytime.
On the horizon, I was wondering what we're actually going to be looking forward to. At least, yeah, it'll be clear. I think everybody here knew the name Weir, and myself included. You know the name, but not really what you guys are actually what you're doing.
We have been guilty in the past of keeping people away. That's not my style, and Pam will tell you that. It's, if you want to come up, scratch and sniff, come and have a go. You could tell us what we're doing good or what we're doing bad, and we take no offence to that. Someone came along and says, we're better than you at that. Okay, can we come and have a look at you? And we've done that with William Cooks. We've done it with Forge Masters. We've done it with Hargreaves. We really do welcome guys coming and testing the systems.
Well, yeah, I mean, it's fascinating sort of technology that you've actually embraced. And the other thing as well, which it's something that we struggle to do, I think, sometimes in the institute, is get young people interested in the traditional skills and using the newer technology. And I think that's certainly important for me, well, for our industry, but I think certainly, again, with Weir, it's wonderful to see that you've taken the time tonight to show us how we are moving forward in the future.
Yeah, and we do focus on attracting talent. And look, let's not sugarcoat it. You guys come up and see this running. If you take interest in it, we're going to try and pinch you anyway. You know, I shamefully make no apology for that. We want to be the hub for where people want to come and work. We went to a show, apprentice evening last week. We've got 140 applicants. 140.
That is wonderful.
So amazing. It does vary from machine shop, maintenance, because we cover every discipline. But MTC, we just had Ellie down there for 2 years, and she came through the ambassador route, the T levels, and we've just got another guy starting, George. So we do try and foster the youngsters and get them involved. My son's there; he's only 25, so he's got a finance background. So I do believe in it. I do believe in the industry, and I do believe we can make a difference.
Oh, ladies and gentlemen, could you put your hands together and thank Lee?
Thank you. Thank you.
And just finally, this is a gesture from the branch. We'd like to
Thank you.
we appreciate you taking the time and sharing new technology.
Yeah.
I can't read them.
Yeah, well, it's fun.
There you go, further back.
Yeah.
Thank you. Cheers.
Thank you, everyone.